Okay, here we are working with translations of entire curves, and our aim in this case is to determine the equation of the curve after the translation or the transformation so that we are able to sketch it. We've been given what the translation is, and we know what the original curve is. And we're going to use that information and some simultaneous equations to be able to find the equation of our transformed curve. All right, so let's see how we're going to do that. Our first step is always going to be to say, well, we know that P primed is equal to our original point plus our translation. But we've been given our original, we've been given what our translation is. So actually, if we can find our original function in terms of our translation, that will help us to be able to find the translated equation. So our second step is to just rearrange this equation so that we've got that P is equal to P primed minus T. Okay, now there is method in the madness because our original points can all be defined in X and Y. Our translated points are X primed and Y primed, and our translation matrix we were given as 1 and -4. Now these are both 2 by 1 matrices, so I can add them. So that's X, Y is equal to X primed minus 1 and Y primed plus 4. And we know through matrix equivalencies, because remember this is now a 2 by 1 and a 2 by 1, I can say therefore X is equal to X primed minus 1 and Y is equal to Y primed plus 4. And that's equation 1 and that's equation 2. And now is when the magic starts to happen, because the third step I'm going to do is I'm actually going to substitute equation 1 and equation 2 at the same time into my function that we're interested in, this y equals x squared. Y equals x squared, okay? And what happens then is that I have y primed plus 4 is equal to x primed minus 1 all squared. And because you've done methods, you should all recognize that that is just the turning point form for the parabola, because I can rearrange that and that becomes y primed is equal to x primed minus 1 squared minus 4. And because when we're working with images, we are actually just working with another equation of another function, we're now going to drop our primes and call it our image equation. But we should be able to sketch this thing because we know how it works. Okay, so our fifth thing is to say, therefore, the equation of the image is y is x minus 1 squared minus 4. And let's just have a look at that. Okay, it says sketch the original and the image and verify. So to sketch y equals x squared, we know that our vertex is at 0, 0. That should be fine. And we'll use symmetry for additional points. So that one should be a fairly easy one to sketch. We know we're at 0, 0 there, and I can give myself a couple of extra points because we're in 2, 4, 2, 4. There we go, and a beautiful smooth curve through those points. Okay, so that's my y equals x squared. And then I have to look and try and sketch y equals x take 1 squared minus 4. So y equals x take 1 squared minus 4. We know what form that's in, so we can say in the form y is a x minus h all squared plus k, and we have our vertex at h and k, so we know that's at 1 and negative 4. I know my a is greater than 0, so it's positive. We have x-intercepts when y equals 0, so we have x minus 1 all squared minus 4 equals 0. X minus 1 all squared is 4. X minus 1 is plus or minus 2, so x will be 1 plus or minus 2, which means that my intercepts are at negative 1, 0 and at 3, 0. And then we have our y-intercept when x equals 0, so we have y is negative 1 squared take 4, so that will be at negative 3. All right, that gives us enough information to be able to sketch this thing. Maybe I'll do it in a different color. So we have our vertex at 1, negative 4. Our intercepts at 3, 0, negative 1, 0, y-intercept at 0, negative 3, and we have a beautiful smooth curve through our points. And this is y is x minus 1 squared take 4. And we've been asked to verify this. Well, I can see that those are exactly the same function. They have just been shifted 1 unit right and 4 units down. So I can say, therefore, solution verified as parabola is shifted 1 unit right and 4 units down.